Hey guys, welcome to part 2 of average value of a continuous function. So let's go ahead and begin with our second example. The table below gives values of a continuous function of f. Use the left Riemann sum with 3 subintervals and the values from the table to estimate the average value of f. So what is the average value of f? The average value of f was the integral from a to b of f of x dx, but we divided by b minus a, or you can bring b minus a as a constant in the front of the integral. It's the same thing. So one of the things you have to be very careful about is when students see left Riemann sum, they tend to ignore other keywords like average. So don't ignore average, but let's go ahead and find the left Riemann sum as we normally do. So if we want to approximate this area under the graph using these points, we're going to use Riemann sums. In this case, we're going to be using left Riemann sum, and we're going from 5 to 17. So it's 5 to 17 of the function using left Riemann sum. We know that we're going to be using the first points of the graph and ignoring the last. So let's go ahead and find the Riemann sum. First, we need to know the bases of these rectangles. We have to use 3 subintervals, so it's from 5 to 9, which is a base 4, from 9 to 12, which is a base 3, and 12 to 17, which is a base 5. So 4 times 23 times the first height, plus 3 times 29, which is the second height, plus 5 times 36. And that is 92 plus 87 plus 180. And if I sum these up, give me a chance to add them up, I get 359. Now 359 does not represent the average value. It only represents the Riemann sum. What do we have to do to this integral? Let me put it in yellow. What do I have to do to this integral in order for it to become an average value instead of an integral? We have to divide by b minus a, which b would be the 17, it's the upper bound, and a is the lower bound, which is 5. So really, 17 minus 5 is just 12, but it's 1 over 12 because it's being divided, and I put it to the front of the integral of the area under the curve, which we already know what this is. This is already 359, and we get 359, and we divide it by 12. 359 divided by 12, and that is 29.9167. Okay, or you can leave it as a fraction. This and this represent the average value of f. Okay, so be very careful when you're reading these problems. You will still be doing integrals using Riemann sums, but if they have the word average, then you know to divide by the base of all the rectangles combined. So let's go ahead and move on to the applications of average value. So starting with the first example from the next page, a study suggests that between the hours of 1 p.m. and 4 p.m. on a normal weekday, the speed of the traffic on a certain freeway exit is modeled by the function s of t, where s is measured in kilometers per hour and t is measured in hours past noon. Compute the average speed of the traffic between the hours of 1 p.m. and 4 p.m. Okay, so let me read that last sentence again. Compute the average speed. Average speed. Okay, so what does this formula give us? What does it describe? This formula describes speed, and I'm looking for average speed. So how do you take the average of speed and still get speed? we know that when we take a derivative, for example, let's say that I have a function x of t, and x of t is measured in kilometers. Okay, taking the derivative of the position function gives me a velocity function, which we know that it's going to be kilometers per hour. Let's pretend that time is in hours. Taking the derivative of velocity gives me acceleration, and that gives me kilometers per hour, or squared. But how do you find average speed given speed? Well, we're going to use the average formula, the average value formula for integrals. And I'm going to explain how this is going to help us find average speed given that we already have speed. So let's just talk about what S of t is. S of t is measured in kilometers per hour. And when you integrate a kilometers per hour, what is your outcome? When you integrate a velocity, you get kilometers. Okay? Now that is not the answer to this problem here. The answer to the problem has to be in kilometers per hour. So why is average value still giving us the same units even though we're integrating? It's because we're dividing by the interval. For example, we're dividing the number of hours from 1 to 4, which is a total of 3 hours. And then when you're dividing a kilometers by an hours, you still get kilometers per hour. So the average value gives you the average rate of change given that you already have the function that represents that rate. So let's go ahead and just complete this function. I've done enough talk already. And if you guys need to better understand what I said right now, you can just replay the video and just try to make the connections. If not, we can discuss it in class. So I want to find the average value. I want to find the average speed. So I first have to integrate the S of t function, which is already measured in speed, from where to where? From 1 to 4. So, and then when I do find my integral, I divide it by the number of hours during during the study, which is the 4 minus the 1, which is 3. So this is 3, and instead of having a long division sign below my integral, I'd rather just write it in the front, 1/3. So when we integrate this, I'm using a calculator, okay? I'm using a calculator, so it tells me that the integral of S of t is 196.5. And then I'm going to go ahead and divide it by the 1/3. And when I divide it, divide it by 3. So when I divide by 3, I get 65.5 kilometers per hour. Because this represents kilometers, 1/3 represents hours in the denominator. So it's kilometers per hour. So whenever you're trying to find an average value of a unit, and you're given a function that is that same unit, then the only way to find the average would be to use the average value formula for integrals. Let's go ahead and move on to the last problem. Find the average value of the function on the given interval without integrating. Graph and use geometry. Okay, so let's go ahead and graph this piecewise function, 3 minus x. We have an intercept of 3, and then we have a -1 slope. So it's down 1, right 1, down 1, right 1. And I wish I had a ruler in this thing, this software. Should be right there. It's perfect. And then we have, oh, okay, but wait. This line only exists from -1 to 3, so I did not do it right. So it's gonna stop right here. So let me draw that again. There it is. Ah, I still messed up. It starts at -1, then it ends at 3. So I'll get it right this time. Okay, and it's closed according to my equality signs. And then we have 2x minus 6 from 3 to 6. Okay, now I see in my graph I don't have a negative 6. I can't be eyeballing negative 6. But if I want to find the value at 3, I can just simply plug it in. And 2 times 3 minus 6 is 0. So it's going to be the same closed hole here. And then it's going to be a rise of 2, run of 1 until I'm at 6. And if I want to find the value at 6, I could do the same thing. That's 2 times 6, which is 12 minus 6. So my height would be right here. Somewhere there. Okay, closed. All right. Find the average value of the function on the given interval without integrating. Okay, so first, what does it mean to have an average value? It means to have the integral have the area under the curve and divide that area under the curve by b minus a. And this is the average value. So let's go ahead and first find the area. So we have an area from here to there, which is a base 3, a height of 3, so my area here is 9/2. And then we have another area from here, from 3 to 6. Height is 6, base is 3, 3 times 6 is 18, divided by 2, it's 9. So 9 over 2 plus 9, let me just write it as 0.5. 4.5, that's easier. 13.5 represents the area from 0 to 6 of this function. Okay? Now, I didn't use integration here because I didn't use the formula, the f of x. I simply took the area under the curve, which is the same thing as integration. Now, how do I find the average value? How do I make this integral an average value? I divide it by the base from 0 to 6. So 6 minus 0, which is simply just 6. So simply I get this 13.5 and divide by 6, and I have my average value. And that is 13.5 over 6. Using a calculator, I'll go ahead and give you that in decimal. 2.25. That is my average value. Now let me go ahead and show you guys before we end this video. Let me go ahead and show you what this really means. Again, I know I showed you by drawing pictures and using the software, animations. So let's go ahead and draw the point 2.25, the height. Here's 2.25 be right here. If I were to draw a rectangle with base 6 and height of 2.25, this area of this rectangle is equal to the area under the curve there. That is what my average value really represents. I hope you guys enjoyed average value, and I'll see you guys in class ready for more detailed discussions.